Hello everyone, introduce myself. My name is Askar with NIM K1325024. In this video, I will explain the limit of a function. Consider a function f of a single variable x. Consider a constant c with the variable x will approach c might or might not be in the domain of f. The limits, to be denoted by L, is the unique real value that fx will approach as x approaches c. In symbol, we write this process as this is read the limit of fx as x approaches c is L. To illustrate, let's consider limit x approach to 1 plus triple x approaching to from its left. The value to be chosen should be close to 2. So, in this table, x equal 1, 1.4, 1.7, 1.9, etc. And then fx is 4, 5.2, 6.1, and what have you observed from the tables? As the value of x get closer to 2, the value of fx get closer and closer to 7. So, limit x approach to 1 plus triple x equal 7. For the graph, the same can be seen from the right, yes, and you can see in the table. Investigate. Limit x approach minus 1 x power of 2 plus 1 by constructing tables of values. Here c equal minus 1 and fx equal x power by 2 plus 1. We start again by approaching minus 1 from the left. We can see in the table x is minus 1.5, 1.2, 1.01, minus 1.0001, and then the fx is 3.25, 2.44, 2.0201, 2.0002001. Now approach minus 1 from the right. The table shows that as x approaches minus 1, fx approaches 2. In symbol, we can write limit x approach minus 1 x power by 2 plus 1 equal 2. To graph, the same can be seen from the left, yes, and you can see graph in this table. Another example, estimate the value of the following limits. Limit x approach to x power 2 plus 4x minus 12 over x power 2 minus 2x. We cannot plug in x equal to because it will make the function undefinite. We can see in the table from the right, x is 205 to 2.5, 2.1, 2.01, and the fx is 3.4. For x.5, the fx is 3.4. And from the left, x equal 1.5, fx is 5.0. From this table, it appears that the function is going to 4 as x approaches 2. From the right, 2.00001, the fx is 3.999, and etc. From the left, when x equal 1.999, the fx is 4.000015000. So the function is going to 4. So we can write limit x approach to x power 2 plus 4x minus 12 over x power 2 minus 2x equal 4. First, notice that there is a rather large open dot at x equal 2. You can see in the graph, this is there to remind us that the function, and hence the graph, doesn't exist at x equal 2. Does it apply to all the given a limit of a function as x approaches to c? The answer is fc. Why? It applies here. Limit x approach c, fx, we can see in the tables, limit x approach minus 1, x power 2 plus 1 equal to, and left table, limit fx x approach c or fc, we can substitute the x to c. So we get fc is f minus 1 equal 2. Limit theorems. 1. The limit of a constant is itself. If k is any constant, then limit x approach c for k equal key. For example, limit x approach c for 2 equal 2, and then example number 2, limit x approach c minus 3.14 equal minus 3.14, and other example is limit x approach c 789 equals 789. The limit of x as x approach c is equal to c. This may be true of the substitution law, because x is simply substituted by c. Limit x approach c for x equal c. So this may be true of as the substitute x by c. For example, limit x approaching 9 for x equal 9, and then limit x approach 0.005 for x is 0.005, and then limit x approach minus 10 for x is minus 10. For the remaining theorem, we will assume that the limits of f and g both exist as x approach c, and that they are L and M respectively. In other words, limit x approach c fx equal L, and limit x approach c gx equal M. The constant multiple theorem. They say that the limit of a multiple of a function is simply what multiple of the limit of the function. Limit x approach c k times by fx equal key times limit x approach c fx. So equal key times L. For example, if limit x approach c fx equal 4, then limit x approach c 8 point fx equal 8. Point limit x approach c fx equal 8 times 4 is equal 32. And then example number 2, limit x approach c minus 11 times fx equal minus 11 times limit x approach c fx equal minus 11 times 4 equal minus 44. And other example is limit x approach c 3/2 times by fx, with the fx is 4, we get equal 3/2 times limit x approach c fx equal 3/2 times 4. So we get 6. The addition or subtraction theorem. The limit of a sum of function is the sum of the limit of the individual function. The limit of a difference of function is the difference of their limit. Limit x approach c fx plus kx equal limit x approach c fx plus limit x approach c kx equal L plus M. And subtraction theorem, limit x approaching c fx minus kx equal limit x approach c fx minus limit x approach c kx equal L minus M. For example, if limit x approach c fx equal 4 and limit x approach c kx equal minus 5, then example 1 addition, limit x approach c fx plus kx is limit x approach c fx plus limit x approach c kx equal 4 plus minus 5 equal minus 1. And Other example for subtraction. Limit x approach c fx minus kx equal limit x approach c fx minus limit x approach c kx equal 4 minus 5 equal 9. Multiplication theorem. The limit of a product of function is equal to the product of their limit. Limit x equal c fx point fx times kx equal limit x approach c fx times limit x approach c kx equal l times by m. Again, let limit x approach c fx equal 4 and limit x approach c kx equal minus 5. Then limit x approach c fx times kx is limit x approach c times by limit x approach c kx equal 4 times minus 5. So we get the answer is minus 20. Division theorem. The limit of a quotient of function is equal to the quotient of the limits of the individual function, where the denominator limit is not equal to 0. Limit x approach c fx over kx equal limit x approach c fx over limit x approach c kx equal L over m, provided m is not 0. For example, if limit x approach c fx equal 4 and limit x approach c kx equal minus 5, the limit x approach c fx over kx equal limit x approach c fx over limit x approach c kx equal 4 over minus 5. So we get minus 4 over 5. And other example, if limit x approach c fx equal 0 and limit x approach c kx equal minus 5, we can write limit x approach c fx over kx equal 0 over minus 5 is 0. And other example, if limit x approach c fx equal 4 and limit x approach c kx equal 0, it is not possible to evaluate limit x approach c fx over kx because the limit doesn't exist, because kx is 0. Power theorem. The limit of an integer power p of a function is just that power of the limit of the function. Limit x approach c fx to the power p equal limit x approach c fx to the power p equal l power p. For example, if limit x approach c fx equal 4, then limit x approach c fx power 3 equal limit x approach c fx power by 3. So we can write 4 power 3 equal 64. And the other example, if limit x approach c fx equal 4, then limit x approach c fx power by minus 2 equal limit x approach c fx power to minus 2 equal 4 power to minus 2 equal 1 over 4 power 2 equal 1 over 16. Radical or root theorem. The limit of the n root of a function is the n root of the limit of the function, provided the n root of the limit is a real number. If n is even, the limit of the function must be positive. Limit x approach c root n fx equal root n limit x approach c fx equal root n l. For example, if limit x approach c fx equal 4, then limit x approach c root fx equal root limit x approach c fx equal root 4. So we get the answer is 2. Other example, if limit x approach c fx equal minus 4, then it is not possible to evaluate limit x equal c root fx because minus 4 not a real number. Limit of algebraic function. Example 1. Determine limit x approach 1 to x plus 1. Solution. From the theorems above, limit x approach 1 to x plus 1 is limit x approach 1 to x plus limit x approach 1 1. We will addition the limit with theorem limit addition theorem equal to limit x approach 1 for x plus 1 constant multiple equal 2 times 1 plus 1. So we get 2 plus 1. So the answer is 3. Example, evaluate limit x approach 0, 3x power 4 minus 2x minus 1. We can answer limit x approach 0, 3x power by 4 minus 2x minus 1 equal limit x approach 0, 3x power 4 minus limit x approach 0, 2x minus limit x approach 0, 1. We will subtraction theorem and then equal 3 times limit x approach 0, x power 4 minus 2 times limit x approach 0, x power 2 minus 1 equal 3 times 0 power 4 minus 2 times 0 minus 1. So we get 0 minus 0 minus 1. The answer is minus 1. Evaluate limit x approach 1 x minus 3 times x power 2 minus 2 over x power 2 plus 1. Check the denominator first. The denominator not equal 0. Limit x approach 1 x power 2 plus 1 equal limit x approach 1 x power 2 plus limit x approach 1 1 equal 1 plus 1 equal 2. It is not equal 0. Solution start here. Limit x approach 1 x minus 3 times by x power 2 minus 2 over x power 2 plus 1 equal limit x approach 1 x minus 3 times by x power 2 minus 2 over limit x approach 1 x power 2 plus 1. We will use division theorem. Limit x approach 1 x minus 3 times x power 2 minus 2 over by x power 2 plus 1 equal limit x approach 1 x minus 3 times x power 2 minus 2 over by x limit x approach 1 x power 2 plus 1, and we use multiplication theorem. Limit x approach 1 x minus 3 times limit x approach 1 x power 2 minus 2 over by 2, and then we use subtraction theorem. Limit x approach 1 x minus limit x approach 1 3 times by limit x approach 1 x power 2 minus limit x approach 1 2 over by 2. So we get 1 minus 3 times by 1 power 2 minus 2 over by 2. So we get the answer is 1. Thank you for watching my video. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.